Hey, physical science ninth graders, it's Monday, April 13th. And we're going to be starting on page, let me look, 469, section 2. 469, we're going to talk about physical properties, physical changes, chemical properties, and chemical changes. Now, physical properties, the amount of something, that would be the volume of something. So here's what I've got right here. I've got some water. Oh, looks like it's about 14 milliliters of water. Okay, now what if I raise it up to 22 milliliters of water? What have I changed? I've only changed the amount. That would be the volume. Probably the mass as well, wouldn't you think? And so is H2O still H2O? Yeah. And so it's a physical change. A physical property is size or volume. Now let's take a look at this Hofmann electrolysis apparatus. Can you say that? Hofmann electrolysis apparatus. If you look real closely, you will see that I'm using electricity. Let me show you. There's my power supply. All right, looks like we've got about 18.5 volts. It's taking 120 from my outlet, alternating current, and changing it to 18.5 direct current. You've studied that before. Anyway, so it's putting that energy into this water and it's breaking it into its constituent elements. That would be hydrogen and oxygen. Can you see that there's a whole bigger puff of hydrogen going up there than there is oxygen? That's because it's H2O1. You guys know that. So it's gathering hydrogen up there. Do you see the volume of hydrogen that I've already made? About that much as compared to the volume of oxygen that I've already made, about that much. H2O1. Physical change in the water or chemical change in the water? The difference is, in a physical change, you do not change the nature of the substance. You keep it the same. The identity remains the same, but in a chemical change, the identity changes. And so this is turning from H2O into two gases, hydrogen gas and oxygen gas. And so you're changing it from a liquid state to a gaseous state, and you're changing it from water into the gases hydrogen and oxygen, which are entirely different than water. They have different properties unto themselves. So it's a chemical change. All right. So now let's go ahead and do another change, and let's see if you can figure out what it is. Let's go ahead and take some of that hydrogen that we're manufacturing. That's only a tiny little bit. Turn off my power supply. I want to put on the safety goggles. Safety first. And I'm going to go ahead and gather up some hydrogen. As long as I keep this test tube vertical, it will stay in the test tube for a while until it diffuses into the air, because hydrogen is less dense than the air. Okay, now let's go ahead and take a bath. If I had 3 hands, this would be better. And we're going to go ahead and light the match. And we're going to go ahead and pop the hydrogen. Isn't that good? Can you see the liquid water rings? Liquid water rings in the test tube? That's because as soon as I formed the water vapor, it condensed in the inside into water rings. So taking hydrogen, combining it with the gas of the air and forming water gas, hydrogen gas, oxygen gas becomes water gas, H2O gas. Is that a chemical or a physical change? Well, that's a chemical change because you're changing materials. But what about when the water vapor got up in here and changed to water droplets? You can see the rings. There was a shock wave that set up there, and so the rings are like bands inside. It was going boop, 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 and that big old wall of air was causing it like a wall and bouncing it back up there and bouncing it back and forth. And so it was depositing water droplets, which appear as rings. And so we call that a physical change. Water vapor becomes water liquid. Water is still water. There's no change in its property, its identity. And so you saw a chemical change. When we popped it, you saw a chemical change. And when it condensed, it turned into a physical change. All right. Set that aside. Know how much time I have? I'm going to go ahead. Physical change in the water. Looks like a physical change to me because the water is boiling. It's H2O liquid becoming H2O vapor. Now this steam cloud here is not H2O vapor. It's H2O droplets. Because by the time it comes from the spout up to about this height, it has cooled and condensed. So down here it's vaporizing, and up here it is condensing. H2O liquid becomes H2O vapor, which becomes H2O liquid again. In the case of water, if you can see it, it ain't a gas. Clouds are not a gas. Clouds are a liquid. And it was a physical change in the water vapor, sometimes called humidity, that turned it into a cloud. Physical change. So physical change, physical change. There is no chemical change going on here. All right. So that's nice. I think you're getting this. So let's go ahead and finish the talk. We're going to go to page 469. You know what I think I'm going to do? I'm going to do my physical property physical change talk tomorrow. We're not in a big hurry, so you stay with me. I'm just going to stop it right here. See ya.